look at that. You subtract them, so it was a minus the negative x to the k. So then if you put them together, you get x to the k, and so you have negative 1 to the k minus 1 plus 1. So the even terms are going to cancel. When you put in 1, 2, 4, and 6, they'll cancel. So here what did I do here? Oh, this is what you have. And then this is just if you evaluate those terms, you can see that they're equal. So if you just put this in terms of odd numbers, 2 to the k minus 1, or 2k minus 1, excuse me, you can see that you're just going to get odd numbers, and that's exactly what happens with this one. It looks pretty. Sorry? Okay. So you have this right here. Okay. So how are we going to do this with L and n plus 1 over n? Okay, so I would like to know where this came from. Because if you just dreamed of that in the shower, then that's pretty scary. So n plus 1 over n, you multiply by 2 over 2, right? Then you divide by 2n plus 1, or you multiply by 1 over 2n plus 1 over 1 over 2n plus 1 to not change the value of the fraction. So then you split this up into 2n plus 1 over 2n plus 1, which is 1, plus 1 over 2n plus 1, right? And then you have this, which is 2n plus 1 over 2n plus 1 minus 1 over 2n plus 1. So the whole reason for this is now this looks like this. So we can use the summation formula.
Do you see what might motivate that math? N plus 1 and n are 1 unit apart. 1 plus x and 1 minus x. It's like there's x up and x down. It's 2x. So how would you get more space? You would amplify things just by multiplying top and bottom by 2, right?
Yeah.
And now 2n plus 2 is 2 units. It's 2 units away from 2n. And then you try to split the right, and so then you split the difference, the same thing up and the same thing down. And then, so it looks like the 1 plus x over the 1 minus x. That's what motivates it.
Yeah. So I mean that was really interesting. So yeah, we're trying for that. Yeah, it's included not. Right? Okay, so then so you have ln of n plus 1 over n. So that's ln of 1 plus x over 1 minus x. So this is the x in this formula. So in for x goes 1 over 2n plus 1. Right? So all we've done is replace 1 over 2n plus 1. So the first few terms written out are that. Okay. Okay, so delta n minus delta n plus 1 is, okay. Yes, so now we put this sum into this, right here. So we have 2n plus, we have the 2 that comes out front, and we have the n plus 1 half, the sum, and there's the x. So this is just 2n plus 1. Inside the summation, we get this, so delta n minus n plus 1 is this, minus 1. We still have that minus 1 from here. But we can start this one here, or we'll just start it at 2 here, because at k equals 1, we have 1. So we'll just start it at k equals 2. Right? So that's some pretty wild stuff. Okay. So now this is important. Delta n minus delta n plus 1 is greater than 0. So delta n must be a decreasing sequence. The successive terms are small, right? Okay, so then this term is series is majorized by this. So the series is going to be, this one's going to have bigger terms, right? Which is a geometric series. So you do a sub 1 over 1 minus r, which is this, which is this, which is this. And then, okay, so we have delta n minus delta n plus 1 is less than this because that's the series that it was majorized by, right? And then you can expand using partial fractions, right? Okay, so now what we have here, if you look, if you just not look at that term, you move the 1 over 4n over and move the delta n plus 1 over to get that. Okay? So this means then that delta n minus 1 over 4n is 8%. Yeah, because, well, if this sequence right here is less than its next term, so yeah, this sequence is going to be increasing.
And that one's going up, the other one's going
No,
down.
it's
The
going
basis
down.
sequence is going down.
And it doesn't make sense to me because this one's you're subtracting terms, so
Yeah, but it's
not intuitively obvious.
No, that's for sure, but there's a little dance that's going on there. Taking away the 1 over 4n is enough to make it go up.
Yeah, I suppose, yeah. It's so funny, this is decreasing, but if you subtract it. Okay, so we want to appeal to the monotone convergence theorem.
Well, we don't have a limit there. We have a very strong belief that since 1 over 4n is going to 0, the increasing and decreasing sequences will hit the same limit. But in principle, you don't know that yet. The one that's increasing can go flow right by the one that's decreasing. They can sort of pass in the night. So you have to force a limit to appear, and you can do that. You know that you have an increasing sequence here, delta n minus 1 over 4n. If you can just hit a bound on it, then you're in business.
Yep. So we just want to show that it's bounded, and then we can use the monotone convergence theorem. Okay. So we have a monotone sequence. All we need to do is show that delta n minus 1 over 4n is bounded above. So we have delta n minus 1 over 4n minus delta n. And we use the difference version, which I wrote down for my own benefit. Okay, so now since we know that delta n is less than delta 1, and I'm assuming that because delta n is decreasing, the first term is going to be the biggest. So we can replace this part right here with delta 1. So then delta n minus 1 over 4n is going to be less than just move delta 1 over. So the whole sequence is going to be bounded above by delta 1 plus 1 4. So by the monotone convergence theorem, this sequence has a limit, and since, so you can see that, add the two sequences together, or add the limits together.
Add the limits, and add sequences termalized. Downward limit of the other sequence has to be named as well.
So evidently. So we've shown that the limit exists. Now here's the part I think I had trouble with.
This is showing that the limit lambda is greater than 0.
Okay. So delta n minus 1 over 4n is increasing. Lambda is greater than delta 1 minus 1 4th.
And delta 1 is 1.
Right. Yes. If you use the formula
For delta 1, we get 1.
right here, there's delta n.
That's why we had to take we couldn't have the minus 1. We couldn't say that. Right?
Yeah, that's really,
This argument wouldn't work.
yeah, that's really cool.
So lambda is somewhere above 3/4.
So where do we get the minus a fourth comes from the bound on
Well,
delta n?
what is the first term in delta n minus 1 over 4n? Delta 1 minus 1 over 4.
Oh, all right, sorry.
And everybody else
Yeah.
is above that, so lambda has to be above that. And
Ah.
since delta 1 was 1, lambda has to be above 1 minus a quarter.
Yes, because this is increasing. See, that killed me last night, that they were coming together. All right.